In this lesson, we're going to look at differentiating certain functions using the chain rule. Why do we even need another rule when we already have quite a few? Well, consider these two functions. Well, this one, we might be able to use one of the rules we already know if we rewrite it as y equals e to the x times e to the x. That's the same thing as saying e to the 2x, because then we can use our product rule to find y prime. That would be e to the x times e to the x plus e to the x times e to the x. And when you simplify that, that's 2e to the 2x. That's not too bad. Now let's look at this other example. I already wrote out the solution to finding y prime, and as you can see, it's very lengthy. So we could use the product rule to do this by rewriting our x to the power 5 plus 2 cubed into x to the power 5 plus 2 times itself 3 times. We can group them in a certain way that we can use a product rule. But there's a lot of simplifying. We need to do some factoring in order to get a more simple looking derivative in the end. You could have also expanded this x to the power 5 plus 2 cubed, so you have each single term, and then differentiate every single term. That's a lot of work too. This is where the chain rule comes in. If you notice these type of functions, there are functions of a function. E to the something is a function, 2x is a function. X to the power of 5 plus 2 is a function, and then sum to the power of 3 is also a function. So what you can do here, you can use the chain rule to do this. It's going to be a lot easier than using your product rule and your quotient rule to do these type of polynomials and functions. Let's take a look at the chain rule. You might have to rewrite this because I realized that I misplaced my brackets here. What I'm trying to say is a function of a function, like f of g of x. If you want to differentiate this, this will be the derivative of f of g of x times the derivative of g of x. And if you have a function of a function of a function, then this would be f prime g of h of x times g prime h of x times h prime of x, and so on. So what I want you to think about is actually think about peeling an onion as you do this. Well, why? Let's look at the pattern. If we look at what we're differentiating first, we're always differentiating the outside first and leaving the inside alone. So we differentiate f, we left g of x alone. And then we'll differentiate the inside, and that'd be g prime of x. So when you think about peeling an onion, you have to peel the outside before you get to the inside. And another thing they have in common, they probably both make you want to cry. Haha. So let's look at an example of actually how to do this. My outside function is going to be something to the power of 9. So I'm going to use my power rule first to do that. I'll bring down the 9, leave everything inside the bracket the same, and then subtract 1 from the exponent. Now I want to think about finding the derivative of the inside function. So that's going to be the derivative of 4, which is nothing, and then the derivative of negative 3x squared is going to be negative 6x using our power rule, and then that's it. Let's look at b. I'm just going to rewrite this as sine x cubed in brackets, because now we can clearly see we need to use the power rule first. We have something to power 3, so that's going to be the power rule. Bring the 3 to the front, leave the inside the same, and then remove 1 from our exponent. Now we take the derivative of the inside, which is sine x. And the derivative of sine x is cos x. And then that's it. Let's do another. Our outside function here is going to be e, so e to the something. We know that e is going to remain the same when we take the derivative of it, the function e. Now we want to take the derivative of 4 root x. Remember that 4 root x can be rewritten as 4 times x to the power of a half. Because we're going to use our power rule here, if you bring the half to the front, you're going to get 4 times a half, which is 2. And then you're going to minus 1 from the exponent, which is negative a half. And that's it. Let's do another here. Now we have function of a function of a function. Just do things one at a time. Okay, so we're going to focus on the outside, this sign. The derivative of the sign is cos. And I'm going to leave everything inside the bracket alone. Now I want to take the derivative of this part. Sine of sine x. The derivative of sine is cos. And then I'll leave the inside alone. Then lastly, we have one more, which is this sine x here. The derivative of sine x is cos x. And that's it. Here's another example, which is more complicated. We need to use a chain rule for our numerator because we have a function of a function. We also need to use a chain rule here as well. And then because this is a rational, we have to use the quotient rule. So let's take a look at just our numerator. I'm going to calculate the derivative of the numerator, calculate the derivative of the denominator, because we do need our derivatives for the top and the bottom in order to use our quotient rule. So this 2 here, remember that also means sine e to the 3x all squared. So that's what we need to differentiate first, is using our power rule. I'm going to bring down the 2 and leave everything alone. And remember, we had to subtract 1 from the exponent, so we're just left with the power of 1, so I don't need to write anything there. Now we focus on the sine part. The derivative of sine e to the 3x. We're just going to focus on the sine. The derivative of sine is cos, and I'm going to leave the e to the 3x alone. Now we need to take the derivative of e to the 3x. E to the 3x, because we're taking the derivative of e, the function e is going to remain the same. Lastly, you want to take the derivative of 3x, which is just 3. So this is what you get for your numerator. I'm just going to simplify this a bit because it just looks like a mess right now. This is also 6 e to the 3x sine e to the 3x times cos e to the 3x. Now let's look at the denominator and find its derivative. We just need to take the derivative of cos and leave the 2x alone. So the derivative of cos is negative sine of 2x, and then multiply by the derivative of 2x, which is 2. In other words, this is negative 2 sine 2x. Now let's put everything together using our quotient rule. We're going to do f prime of x. In this case, we're going to do the derivative of the numerator. Multiplied by g of x, our denominator, minus the derivative of our denominator multiplied by our numerator. All over our denominator squared. And then that's it. So go ahead and do the try it yourself questions. There's 3 of them just below, and then when you're ready, please press play to see the solution. All right, so here are the solutions to those 3 questions. Here you want to leave e alone because when you take the derivative of e, it's going to be the same thing. So we're going to write e and everything else attached to it, multiplied by the derivative of 2 tan x squared. The derivative of tan is secant squared, and then we're going to leave the x squared alone. Remember, this 2 is just a coefficient, just a number. Just leave it as is there. And then we'll take the derivative of x squared, which is 2x. And then that's it. And the second one, we want to take derivative of secant. Derivative of secant is secant x tan x. In this case, we're just going to plug in whatever number or whatever they have inside our bracket, which is 4e to the 2x. So secant 4e to the 2x times tan 4e to the 2x. Then we'll take the derivative of 4e to the 2x. Because we have a function of e, it remains the same once we take the derivative, and then we'll just take the derivative of 2x afterwards, which is 2. Lastly, again, because we have a function of e, taking the derivative of e, it will look the same. So it's e sine x squared. Then we're going to take the derivative of sine, which is cos, leave the x squared alone. Then lastly, take the derivative of x squared, which is 2x. Let's try finding the second derivative of a and b. So second derivative just means you're going to take the derivative twice. So you're going to find y prime and then find y double prime after. The derivative of cos is negative sine x, which is positive sine x. Then we'll take the derivative again, because we're looking for the second derivative. Derivative of sine x is cos x. So we're just using what we had from y prime to find y double prime. Let's do this with b. I'm going to use our chain rule here. Derivative of tan is secant squared, and then leave the 4x alone. Then we'll take the derivative of 4x, which is 4. I'm just going to simplify this a bit. And then we'll take the derivative of y prime. I'm going to leave the 12 alone because it's just a number. Then we want to take the derivative of secant squared. So the first thing you need to do is bring down the 2, subtract 1 from the exponent, so that's just going to be 1, and then leave the 4x alone. Then I want to take the derivative of 4x. Sorry, we still have to take the derivative of secant. We didn't do that yet. We used the power rule. So the derivative of secant is secant x tan x. And in this case, we're doing 4x, so secant of 4x times tan of 4x. And then now we can differentiate the 4x, which is 4. So go ahead and do that. Try yourself question, find the second derivative. Okay, so here's a solution to that. Try it yourself. You're going to differentiate every single term first. So that's 8x plus e to the x minus cos x, and then we'll differentiate again, which is 8 plus e to the x plus sine x, and that's it. Let's just quickly touch base on finding the derivative of the exponential function. This is another one you need to remember. And we're just going to apply it. So when we take the derivative of any number to the power of x, is going to be the same thing multiplied by ln of the base. So I'm just going to apply this. Y prime is going to be 3 to the x ln 3. Let's do b. We have to use a chain rule here, but I'm going to write out exactly. It says a to the x, so just whatever you see. 4 cos of 3x multiplied by ln of the base, which is 4, multiplied by the derivative of cos 3x, which is negative sine, because you do cos first, leave the 3x alone, then take the derivative of 3x, which is 3, and you just leave it like that. And then do it, try yourself, and just to make sure you got the same answer. And that's it.